Okay, this is part 2 of lecture 7. I shall start with proof of Heron's. So, part 2. Okay, I'll state it again. Heron's formula. It says the following. Area of a triangle with given sides would be equal to the square root of the semi-perimeter times s minus a, where a is one of the given sides of the triangle, times s minus b, b being the second, and times s minus c, c being the third side. So where ABC are lengths of the sides of a triangle, and S is the semi-perimeter of the triangle defined as A plus B plus C over 2, so the sum of the lengths of the sides of the triangle divided by 2, otherwise known as the semi-perimeter. Okay, so the proof is divided in 3 parts, parts A, B, and C. In part 2 of this lecture 7, I'll talk about part A and part B, and then the third part of the lecture 7 will be part C of the proof. Okay, so let me just draw the picture first, and then we'll take it from there. Okay, so I have triangle A, B, C, and the side AB, let's say, is of length C, BC is of length A, and AC is of length B. Okay, so let ABC be any triangle, with sides A, B, and C, and radius R. Proof, part A of the proof. So let triangle ABC be any triangle with sides A, little b, little c, and a circle of radius r, some radius r, is inscribed. Okay. So I have so that's the center. Let me call it center O. So before I move on, let me draw some things. So this is radius. This is also radius. You can draw the perpendiculars from the center to wherever the sides of the triangle touch the circle. Okay, that is possible. So these are right angles. Okay, and let me name them. This is part D, oh, not part D, point D. This is point E, and this is point F. Okay, so, and before I move on, let me connect these other dots as I will need them. Okay, so what do we have? Triangle AOB, the right triangle AOB. Triangle, what is area? I'm sorry, area of triangle A, this is point O, the center, AOB. That would be the line AB times the height OD, which is the radius of the circle. So area of triangle AOB, it is equal to AB, the line AB, times R, because OD is the radius R, times R over 2. Well, the length AB, I called it little c, so this is nothing other than half times c times R. So this is area of triangle AOB. What about area of triangle AOC? AOC. Area of triangle AOC would be half the base, which is AC in this case, times the radius R, which is OF, but AC is what we called little b, so I have half b times R, and oops, I forgot to write here AOC. And area of the other third triangle that we're considering, area of triangle BOC, BOC would be the line BC times R, same radius OE, over 2. BC is what we called A, little a, so half A times R. Okay, you can think of the entire area of our triangle ABC as made of the areas of those triangles with the dotted sides. So the big triangle AOC, its area can be seen as area AOB plus area BOC plus area AOC. Okay, so that would be area of triangle AOB plus area of triangle AOC plus area of triangle BOC. BOC. So that's the same as saying 1/2 CR plus 1/2 BR plus 1/2 AR, or it is equal to half R times A plus B plus C. This is the same as saying R times A plus B plus C over 2, or R times S. So here's the first connection between the area of our triangle, arbitrary triangle ABC, with the semi-perimeter. Okay, so that would be the first part. Okay, part A. Now part B. For part B, we are also going to use the very same picture. So let's see. Triangle ABC has been decomposed into 3 pairs of congruent triangles, and I'll tell you in a minute what they are. Has been decomposed into 3 pairs, of congruent triangles. Okay, what are they? Okay, so the first pair would be these two, then these two, then these two. Okay, so the first pair is triangle AOD. Triangle AOD is congruent to triangle AOF. This is one pair. The other pair is triangle ODB with triangle OBE. So triangle ODB congruent to triangle OBE. And the third pair is triangle FOC with EOC. FOC congruent to triangle EOC. Why are these triangles congruent? I'm not going to write it, but they are all congruent, all by the angle-side congruence scheme. All right, so since these 3 pairs, we have these 3 pairs of congruent triangles, then I can deduce the following. So from these 2 triangles, since they are congruent, I can say that AD is equal to AF, because they will be looking, so equal sides are looking over equal angles. All right, so from here, we can say that AD is equal to AF. Since these 2 triangles are congruent to one another, I can say that DB is equal to BE. Oops. So DB is equal to BE. And from here, I can say that CE is equal to CF. CE is equal to CF. Further, I can talk about angles. Angle AOD is equal to AOF. So this angle is equal to this angle. So angle AOD is equal to angle AOF. In this other pair of triangles, I can say that DOB, so angle DOB, is equal to angle BOE. Angle BOE. Let me mark them green. Okay. And for the next one, I have some blue ready. So the next pair would be EOC, angle EOC equal to COF. So this would be your blue ones. Okay, hopefully is visible. All right, so far so good. Now I'm going to investigate the following. I'm going to actually extend the line BA to point G. Extend AB or BA rather. And mark on that extension point G. This is point G, such that AG is equal to CE. So this length AG is the same as this other length here, CE. Okay, and then I'm going to investigate the whole entire length BG. So let's see what I have. BG is equal to BD plus DA plus AG. Let me write that. BD plus DA plus AG. So I'm going to substitute each of those with something else that I know about them. But before I do that, writing BD plus AD plus AG is the same as multiplying each of those by 2 and dividing by 2. It's exactly the same algebraic statement. So this is the same as saying half times 2 times BD plus 2 times DA plus 2 times AG. Okay, multiplying each by 2 and dividing by 2 at the same time, algebraically speaking or quantity wise, I'm not really changing anything. All right, so now I'm going to substitute instead of 2 times BD, BD from here, BD is equal to BE. So instead of writing 2 times BD, I'm going to write DB plus BE, since they are equal to one another. So this is the same as DB plus BE. So these two is the same, plus DA. Well, DA is the same as AF. We show that here. So instead of writing 2AD, I'm going to write AD plus AF. AD plus AF. Okay. And 2AG, well, what can I do about AG? Well, before I don't know. AG is the same as CE, no? We made sure of that. Extend BA and mark point G such that AG is equal to CE. So instead of AG here, I can write CE. But 2AG would be 2CE, but CE is equal to CF. So instead of writing 2CE, I will write CE plus FC. I'm sorry, what am I saying? AF, yes, FC plus CE. This is the equivalent of 2AG. All right, we did this by construction, so it's all justified. All right, so I'm going to regroup this. So BG is equal to, since I have all pluses here, I can regroup them as I want. So I can say I leave the half alone, and then I will pair up BD with AD, BD with AD. So this is the same as BD plus AD plus BE and CE, BE plus CE, BE plus CE, plus AF plus FC, AF plus FC, AF plus FC, AF plus FC. Here they are. Okay. Well, what is BD plus AD? Is the little c. So this is equal to half. This is equal to little c. BE plus CE is equal to little a. And AF plus FC is equal to little b. So the entire line BG turns out to be half A plus B plus C, which is what? That's the semi-perimeter of the triangle, which we called S in the very beginning. All right, so what do we have? So S minus C, we just proved that the entire line BG is equal to the semi-perimeter. Okay, we just said that. Now, S minus the quantity C is the same as BG minus AB. So BG minus AB, this is the same, this is the quantity S minus C. Okay, and that is equal to AG. Good. What about S minus B? What that is equal to? Well, S minus B, it would be equal to BG minus AC, because that's what AC is called, little b. So it is equal to BG minus AC. Well, BG, after all, is the sum of these three parts. So I'm going to, again, rewrite that. So BG here, not BC. BG minus AC. But BG itself is equal to BD plus AD plus AG. BD plus AD plus AG minus, well, AC is made of AF plus FC. AF plus FC. Let me see if I can work with this now. So this is the same as, I'm just going to drop the parentheses and I'm going to regroup as convenient. So this is BD plus AD. AG is the same as CE by construction. So instead of AG, I'm going to write CE minus AF. AF is equal to AD. So instead of AF, I'm going to write minus AD. Okay. And FC is equal to CE plus CE. Well, let me see what that is equal to. So plus C minus this C, they cancel out. This AD minus this AD also cancel out, so I'm left with BD. Okay, so the quantity S minus B is as long as the line BD. So this line here is equal to S minus B. Okay, and let me see what would compare with the quantity S minus A. S minus A would be, well, S minus A would be the entire line BG, which I just said is equal to S, minus BC, minus BC. All right, So again, the same idea. I'm going to replace BG and BC with whatever they equal. So I will have BD plus AD plus AG minus BE plus CE. Again, things will cancel out. CE will cancel out with AG, and then a BD will cancel out with BE. Why? Because they are equal to one another. And you will be left, so this is cancelled with this is cancelled with this, and you are left with AD. So AD is this length here, so that length turns out to be S minus A. Okay, and that is the end of part B of the proof. So end of part B of the proof, and also end of part 2 of the lecture. So part C is the last part of the proof for Heron's formula, and there will be just the part 3 of lecture 7. See you in a minute.